Hi, it's Saturday morning. Well, it's almost Saturday afternoon. All right. So I'm trying something new. Okay. I Yesterday I got approved for a beta of the being able to go live from my PC. So I know just to show a little something of what I look at most days. So here I do a lot of machine learning, deep learning research for my thesis, and I'm gonna show. I'm gonna do a little bit of show and tell. Uh, so part of my my trial is going live, and this is my world. Sitting talking forever without doing something is not quite what I do. This is what I do. So, all right, so I'll just go over some of what I've done. I have a data set which I collected from a sensor, and I collected brainwaves data. I can show. It's this device, you can use it, actually, you can use it for meditation purposes, and I I use it to collect brainwave activity based on what activity you're doing. It basically goes on your head, and there there are 5 channels that I collect data from. Typically, when you go to the doc for, say, like a sleep study or something, you you have all these electrodes all over your head. In this case, it's only 5 of them that's being collected. And there's a lot of neat stuff that you can do with that. So I'll show you in a bit. This is for entertainment purposes. All right, it's this is, thanks for joining. All right. So basically the data sets here, you need to declare a lot of import a lot of things here, and that's what that is. I could run everything, at runtime, have the whole thing run, but I'm going to show you what the data looks like in a moment. Although, let's re-import. All right. So here's the thing with this device. You can collect brainwaves data, accelerometer data, gyroscope, and PPG, and you also can collect data about the device itself. The older version, sorry, I'm not going to turn this into a lecture, but you know, if you're curious, okay. So I collected data sets. One when the participant was happy, sad, fearful, and angry. And you can see here, this one is only 236 records. I have others that are like, 600 and something thousand records. But just for today, we're going to play with this one. So time, date, time, but TP9, AF7, AF8, up to here, this is brainwaves data. And then there are the other, if you're looking at the data and the temperature increases, maybe that's not good data, because the temperature, when I first started, I thought the temperature was skin temperature because this is something you have against your skin. I contacted the manufacturer. Nuh-uh, it is a safety mechanism for the device, you know. So if you collect data and the device was overheated, you know, right there, maybe the data's no good. All right, so I'm not going to explain every bit, Bob, I'm doing. So here, from that bigger data set, I was able to pull out just what I needed. The EEG data and the label, meaning what kind of data it is. So we can call this Saturday morning lecture, okay? Yeah. So if you're snoring right about now, that's okay. I'm trying something new because it's part of the trial to be able to stream from my PC, which is kind of important for me as a gamer. Uh, I'm sure you've seen some, if you've seen some of my lives where I'm playing a video game, it doesn't quite work the same, okay? And do excuse the mess. This is my cave. As I said, it's Saturday morning in my cave, okay? All right, so we pull that, and here we can describe the data. You know, if you want it, you want to look at certain, you want to have a look at the data. This is the describe, gives you that. And another thing here, if you notice, we have words for the label. And there are times when you don't need words. Let me, that's not the one I used. EEG, there we go. So here, before, basically convert it into numbers. And there is a one-line code that could be done and do integers, but we're not concerned with that. Now for me to do some calculations later on, I need to define x and y. And you'll see why in a moment. And so this is what the data looks like. Not very pretty, but yeah. There'll be pretty pictures coming in a bit. Yeah. So basically divide up that. So we had this big ass data set, and we took what we wanted out of it and we divide it into little containers. Now we're going to divide things up some more. So here's the thing about machine learning, deep learning. When you're trying to learn, you need to teach them, you need to create a model, teach the model, and test the model. And if you notice, I divided everything to x and y. So y is the output. That's the that's where all the classes. Trying not to turn this into a damn lecture, but anyhow, this is where I excel. So I'm gonna use that. Anyways, okay, that looks good. All right, so above, you notice I divide x and y. I need a training set, a test set of x and y, and that's what this is. And basically the test set is going to be 25% of the original data set. And random state here, what this is, I'm not sure why I'm doing this, but oh well. Random state, if you put none, every time you run the model, things will run a little differently. But if you use an integer between 0 and 42, it runs the same way. I'm still playing with that. That's called a hyperparameter. Basically a value that you could put into a model and it can change the behavior of the model. So anyway, so let's run that. And just for curiosity's sake, we're going to look at the shape. Although I think I might have done it later on, but that's and yeah, let's do Y. Okay, do I want to? Yeah, I'll do that one too. So what we're doing here is I want to show you the results of splitting things up. Did Y test is what I need to do. All right. So did I mess that up? Yep, I did. This should have been a test. All right. So if you notice here that only 177 records. What this means here, it's 177. It's showing you the matrix of the data. So you have 177 records by 5, and those are the 5 parameters. Now, this is the training data, and then this is the label. This is what you want based on what those 5 values in a row is. The answer is in here. Now, 25%, this is the test data. Is anybody here? If you're snoring right about now, it's okay. All right. Yeah. So this is what I do. So the kind of model that I'm running here is a gradient boosting model. Now think of having, say you had a wall garden, and you have, say you were watering a wall garden. Let me set this up properly. You have 3 rows, and then there's a garden here, and a garden here, a shelf where you have your plants, and then another shelf and another shelf. That's one way of thinking of it. So you have one, you water that one, then the water comes down, the water from there comes down and down and down. That's kind of one way of saying it. Or, let me just explain it this way and stop trying to. Anyways, all right. All right. So the first part of this model is to fit for decision tree. So we run the first one, and that is fed into another decision tree, and then another decision tree. Now you sum those 3 up, and now you build the model. So the model is based on 3 decision trees. And here, so now we're going to predict. We have an output and a score, an accuracy score. Yeah, it's 84, it's 85%. Now, we're going to keep going. I'm going to go back up and do something and see what happens. But here, this is called confusion matrix. And what this is, nice, I can't really zoom in. Anyways, so what this is, it gives you a visual of whether your model is going in the right direction or not. Now, here, how to know when you have a good model? The numbers are going to be on the diagonal. The less numbers, these values, all the non-diagonal numbers should be 0, or darn close to 0. Now, in this case, let's see, 1, 2, 3, 4, 5, 6. Okay. This is a good model. Okay, it's not perfect. There's a lot of fine-tuning that could be done to make it even better. But this is like one of those quick visuals that you can see. Okay, it's going in the right direction. And then here we have a classification report, and it gives you a breakdown. You know what these are all metrics. I won't go into that. That's I don't want to hear snoring. Well, can't hear anything, but that's beside the point. But the accuracy of the model is 85%. Now, the best, and this here, let's see. Okay, so we built a classifier based on these three, 1, 2, 3, the summing of those guys, and we fit it. And then we did another run through using the best estimate, and the best estimate was 33. So, you know, it's not just you do one model and boom, you're done. It's you play with these things and see how you can tweak the numbers. And I am going to just run everybody. So this is another way you can just run the whole thing. I was trying to go through and show, but here are one of the things that you can do, and it's called tuning, fine tuning, and this is where you use hyperparameters. And here are some that you can really play with, and it can alter things. So let's see. The learning rate is one of those when you're trying to fine tune a model, you start with a learning rate of 0.01 and then you work back and see what happens. So yeah, what did I do different for this one? Yeah, I did do something different. Okay. All right. So there were two. You notice here we started with this model, and we started with a large amount here, 120, and then we went through and see which ones, you know, were showing errors. You know, we kind of played with, without going into deep detail on how this works or anything. We ran the model with a large number and saw how that did, and based on, you know, a mean squared error, which ones did a good job, and then use that count on how many of those, and then you end up with you're running the best. Be 33. Let's hear the estimate of 33. So without that, without running, say running the whole thing, the 120, you end up with an accuracy of, oops, back here. Where did I go? Okay, you end up with when you run the best number of estimates, you get 86, and above, we were getting 85. Although, if you keep running it, the numbers will keep improving. Anyways, so there's that. Now, all said and done, in this case, these are some of the metrics that I am collecting. And, you know, the accuracy. The thing about accuracy, it's not always, oh, how do I, you know, the best way I can explain this, I will show you a model. Actually, no. I as you can see, I have quite a few models that I'm running and I'm playing with. But the other day I did a run on probably a dozen models and the ensemble learning. And here's a little bit. Oh, you know what? I am what I am. Ensemble learning is one where you can take other models and put them together. And gradient boosting is kind of like, but it's very different. Um, Basically, you're taking, they're pretty similar. Anyway, so I had ensemble learning, and the heck was the other one? I had another model that came out like 83%, while ensemble came in at 81. And when I looked at the confusion matrix for ensemble learning looked more promising than the other one. So I did a little bit of tweaking of the hyperparameters, changing things, and those changes didn't affect the one that looked perfect. The one that didn't perform as well at 81%, 81.4, shot up to like 85% accuracy. I guess the moral of the story, the shiny things aren't always, the best anyway. So I went from using that other model to ensemble learning, and then I came across gradient boosting. That one performed even better. So so here we so the moral of the story, accuracy scoring is not always the best judge of what's correct or not. And there's recall and all of these. Okay, so say you had 4 by 4 and we have the true positive, true negative, false positive, false negative. And that's what these values represent. And Matthew's coefficients correlation, that one takes into consideration everyone. These guys take a combination of the others. So let's rerun this. So the accuracy, as you can see here, well, it doesn't break it down. I actually have other code where it actually does the computation. Here it's using a method from Keras. Anyways, so here. So here's the so all the numbers are pretty good. They're all in the 80s, high 80s. Yeah. So specificity, it's more like the true negative rate, true positive. Anyways, so all that said, I didn't mean to turn this into another conference tutorial, but that's what I do, and that's what I'm going to be doing with my Saturday for a little bit. I have some other models that oh, the other neat part about machine learning and these models is when you combine them and the neat things you can do. So this is gradient boosting. Let's see which other one I want to. Not that one. All right, so I'll show the decision tree one. And I'm using Google Colab for more control, maybe PyTorch, which is what I'm going to be moving to, where things are more offline. A lot of these things you can run in Python, or you can run them offline, but this is pretty okay. So this is my smaller data set. I have a bigger one and it would take a long time to load, and let's run this one. If you notice, so see, And you have a neat little tree. Okay. And yeah, that looks good. Now here's the thing. It's it has an accuracy of in the 70s, but this guy uses multiple um, multiple installments of decision tree classifier and able to get an 86% accuracy. So my whole point is that you can have a poorly performing model, and if you combine them, you can actually make a more powerful model. So yeah, this one isn't doing that great. You know, the results are in the 70s, except for the true negative. Yeah, yeah. So there's that. And the trees are cool. Yeah. All right, let's see. All right, is anybody in machine learning or computer science or curious? Anybody curious, or is it just me? No? All right. So I do have some other models. I'm wondering if I should run like this one I'm working on. The the results are not that great. Yeah. Yeah. I'm this is where I'm gonna be picking up after. Yeah. Did I get accuracies on this guy? Probably not, because I'm still. See, I'm building a convolutional neural network, and this one works great with images, but I'm not working with images. I'm working with data points, and I need to. That's what I'll be working on in the next couple of minutes when I get offline. So, getting rid of the good old juicy errors. And let's see, I did do a simple multi-layer perceptron. Yeah, I'll show that one. I don't recall what the accuracy was on this guy. Yeah, the accuracy super suck. But yeah. How do we say super suck? It's super suck. Yeah. So basically you want your accuracy on your training data to be as close to 1 as possible. Although I have one that I did. No, not that one. Anyways, so thank you for stopping in. I hope you enjoyed watching. This is like what I do, trying to find the right model to translate to recognize human emotions, and in this case, it's brainwaves, human emotions from what we're thinking. So sorry, there's no dancing and twerking here. It's all brain stuff. So I hope you enjoyed. And yeah, if you have any questions, yeah, you can drop a comment. It'll be appreciated. Anyways, I am gonna log off for now and go look at the video and see how it worked, because this is my first live from my PC, and this is pretty cool. All right. Have a good Saturday. Bye. Yep. And